3/4 solving exponential and logarithmic equations. There are two basic strategies for solving exponential or logarithmic equations, and the first is based on the one-to-one properties. The second is based on the inverse properties. For a being greater than 0 but not equal to 1, the following properties are true for all x's and y's for which log base a of x and log base a of y are defined. A to the x power is equal to a to the y power only if and only if x and y are equal to each other. So if the bases are the same, the exponents must be the same in order to be equal. We could say the same using logs, really, because we are rewriting this. So log base a of x is equal to log base a of y if and only if x and y are equal. Our inverse properties say that a to the log base a of x is equal to x. So as long as the base here is the same as the base in the log, we can basically just cancel these out. Same goes here. As long as the base and the base here are the same, they can cancel out, and we're going to get x. So we're going to solve each of these simple equations using logs and exponent rules. So 2 to the x power is equal to 32. Really, I'm just saying to myself, well, what do I have to multiply 2, how many times do I have to multiply it to get to 32? So that is going to be 2 to the x is equal to 2 to the 5th. I can rewrite 32 as 2 to the 5th, so x is equal to 5. In this next one, I see subtraction, so I can turn that into division. Log base 4 of x over 8 is equal to 0. Then I can rewrite this. So 4 to the 0 power is equal to x over 8. 4 to the 0 power is actually equal to 1. So 1 is equal to x over 8. I'll multiply. X is going to equal 8 times 1, or just 8. Very similarly, in this next one, we have the natural log of x minus the natural log of 3. So that's the natural log of x divided by 3 equals 0. Remember, natural log really just means log base e. So that's e to the 0 power is equal to x over 3. That's going to give us 1. So x is going to equal 3. All right. Here we have 1/3 to the x power is equal to 9. Well, I have 1/3 to the x. 9 I can write as 3 squared. So if I want to turn that 3 into a 1/3, I just need to make the exponent negative here. So if I say 1/3 to the negative second, that's also going to give us 3 squared, which is 9. So then I can say that x equals negative 2. Then I have e to the x is equal to 7. Okay, so really what that means is I could rewrite this as the log base e of 7 is equal to x, or natural log of 7 is equal to x, and I could just use my calculator to evaluate that. And then here, again, think that's log base e. E to the negative 3, which is something I can get in my calculator, is equal to x. But it can get more complicated. And when it gets more complicated, we have some strategies we could use. We can rewrite the original equation in a form that uses the one-to-one properties. We can rewrite an exponential equation as a log, or we can rewrite a log as an exponential. When our equations can get really messy too, and they use 2 or more exponential expressions, you can use a procedure that's sort of similar to this that's going to require some factoring. So let's take a look at solving this expression. We have e to the 2x minus 3 times e to the x plus 2. So think of that e to the 2x as e to the x squared, because really we would multiply the x and the 2 there. This looks like a quadratic. So I can think of that as e to the x times e to the x. They both have to be negative, so we have a 1 and a 2. And now I can set each of those equal to 0 using the zero product property. E to the x minus 1 equals 0, and e to the x minus 2 equals 0. That's going to give me 1, and then I'll take the natural log of 1 is equal to x. So whatever that works out to be, the natural log of 1. And then here I'm going to take the 2 and add it. And then the natural log of 2, or log base e, is equal to x. All right. In In order to solve a logarithmic equation, you can also write it as an exponential, and that can be very helpful here. So the natural log of 3x is equal to 2. Remember, that means log base e of 3x is equal to 2. So that means e squared is equal to 3x. Remember, e is just a number. We'll divide by 3. So x is going to equal e squared divided by 3. All right, for this next one, we can use our one-to-one properties. So since they're both log base 3, I can just say that whatever is on the inside of those parentheses is equal. Subtract the x, add the 1, and divide. Whoops. All right, for this next one, let's start to get things away from the natural log. So we'll subtract the 5. We'll divide. And then we're going to switch this. So remember, that's log base e. That means e to the negative 1/2 is equal to x. Again, we can use our calculator to get a value there. All right, we'll divide by 3 in this next one. And then we'll rewrite this. So that's 4 to the 3rd power is equal to 6x, and then divide by 6. 4 to the 3rd, let's see. 4 times 4 is 16, times 4 is 64, divided by 6. And 64 divided by 6 is going to give us 8/3. Sorry, no it's not, 32/3. Okay. Because the domain of a logarithmic function generally doesn't include all real numbers, you should be sure to check for extraneous solutions. Remember, we can't take the log of anything less than 0. All right, so, or really of anything less than or equal to 0, I should say. We can't even take the log of 0. So then we're going to check for these extraneous solutions. So we'll solve it first and see what happens. We can use the addition rule to make this multiplication. We can also use that rule on the right and turn that 2 into a squared. Okay. I'm taking the natural log of both sides, so that base is the same. So I have x minus 2 times 2x minus 3 is going to equal x squared. I can FOIL. So that's going to give us 2x cubed, or 2x squared, sorry, minus 3x minus 4x plus 6 equals x squared. I'll subtract x squared to get 0 on the right. Factor. And use the zero product property. So I'm going to get 1. And I'm going to get 6. And we just want to double check that if I plug in 1 or I plug in 6, that whatever I'm taking the natural log of is greater than or equal, or greater than 0. So if I take log of x, x has got to be greater than 0. All right, so here, if we plug in 1, this is 1 minus 2, that's going to give us a negative. So that is an extraneous solution. It doesn't work. But if I plug in 6, that's positive 4. I can take the natural log of that. 2 times 6 minus 3, that's 12 minus 3. I can take the natural log of that, no problem. And if I plug in 6, I can take the natural log of 6. So x equals 6. Next one, same concept. They both have a log base 10. Remember, I don't technically have to write that 10 there. But I can use that addition rule to multiply. Okay. Remember that 10 is really the base, so 10 to the 1st power is equal to that stuff in parentheses. I can multiply. I can multiply. So that's x squared minus 9x. I'll get the 10 to the other side. And I'll factor. Zero product property. And then we have to check. So if I plug in -1 right away, we have a problem here, so that's not the answer. If I plug in 10 and 10, log of 10 is fine. Log of 10 minus 9, which is 1, also fine.